Good morning, ladies and gentlemen. I'm Jonnro Erasmus. This is quite fortunate. I had a few slides discussing the competitiveness of manufacturing in South Africa as a motivator for what we're proposing here. I'll just briefly skip through those now because we just had about a half an hour of that. What I'm actually presenting is essentially then an idea, something we're doing at the CSIR to perhaps help with this downward spiral of competitiveness in our manufacturing sector. So that's directly taken from the Industrial Policy Action Plan. It shows exactly what Jonnro just showed now, that we have a downward trend in our manufacturing as a percentage of GDP. Even though the actual volume or the value of our manufacturing has increased, it's underperforming, as Jonnro said. So a little bit more worrying, though, is that the jobs created by manufacturing it's slightly increased from 1970 to 1990, and it's been sort of flat, and then it decreased a little bit again. And that shouldn't be like that. Yes, we do have a fairly strong service industry in South Africa, but we are a mineral-rich country, and we should make better use of our minerals, and the way to do that is to manufacture locally. So if we look at the manufacturing circle, this is from the, if we look at manufacturing in South Africa, this is from the manufacturing circle. So it currently employs about 1.7 million people. It is, for every R1 invested in manufacturing, it typically gives R1.13 of value back to the economy. It is among the top three multiplier sectors in terms of job creation, value addition, export earnings, and revenue generation. So it's a very valuable industry for South Africa, and we should exploit it better. Obviously, it also provides the base load and scale for the national infrastructure. So if you think about something like the National Development Plan, we can't just build power stations and railway lines without manufacturing the things that make up that power station or railway line. We need to manufacture it. And unfortunately, I think most of it we are importing it. And then, as I said, the means to beneficiate or to add value to our mineral resources or natural resources, it lies in manufacturing. So if we look at the current situation, we've now seen, as you saw, the competitiveness isn't doing that well in South Africa. We do have some fairly good, in my opinion at least, government legislation or policy in terms of the National Industrial Policy Framework, the NIPF there, and they very clearly state that manufacturing drives employment and growth in the economy. We saw now that it's directly linked, it's directly related to the growth of our economy is the manufacturing growth as well. Expanding on that, we have the Industrial Policy Action Plan, I think that's the correct name, where they identified 16 industry sectors in South Africa for government support, and in an attempt to increase local production. There's a problem though, and I'll quickly show you all those 16. And it's that manufacturing isn't simple anymore. If you think of a modern luxury car, it's not a mechanical object anymore. It's mostly these days almost electronics, or the iPhone that was mentioned, or aeroplane. It's not. Even in the mechanical side as well, you've got composites or additive manufacturing. It's not a simple exercise anymore. And we need to understand that to improve manufacturing is a bit of a paradox. You need better engineering, actually. And what we're proposing here is a way to improve or to enable engineering or product design so that we can improve our manufacturing. So these are the, and I think there's 17 on this, I'm not sure why, but these are the industry sectors that's targeted by IPAP. And if you look around, you'll see there's boat building, nuclear, advanced manufacturing, so aerospace and defense, electrotechnical, there's forestry, agro-processing. If you think of those big vehicles, those are very complicated things. Plastic chemicals, most of these, in fact, quickly counting, I think it's 14 of them require fairly sophisticated engineering and manufacturing techniques. It's not just a simple exercise. And we propose that the thing that drives that, the thing that makes it possible to do these complex activities is information. And I'll show you now why we say that. So So this is purely an illustration. It's done by a company, A.T. Kearney in Germany, where they try and show that we are now entering an age where we struggle to deal with this complexity. So that's what they say. So not necessarily the brain that struggles, our brains that struggle to deal with it, but our current tools and our current techniques, the way we approach enterprise. We don't currently have the ways really to deal with the complexity that we're running into. So if we look at the contributors of this complexity, and there's sort of three categories of this. There's the complicated product itself. Sure, we know products are consisting of more and more little pieces. So you will also have mass customization these days, and even to the extent where every single one of the products or the components that go into a manufacturing line may be different from the previous one. You have more and more electronics and software that's being added to even traditional products, and obviously the servitization as well, where as an example, I think most of the people know about it, where Rolls-Royce no longer sell aeroplane engines, they sell thrust hours as a service. On top of that, we also have the sort of the environment, or the enterprise bit, so the place where the products are created and supported, support in terms of maintenance and logistics and so on. So we have advanced manufacturing techniques. I think we've discussed many of them in this conference as well. As we said, the more components that the product consists of results in more suppliers. So you've got a more complicated product, but you then necessarily have a more complicated or even a complex supply chain. And then even worse than that, we no longer have a closed economy. We've got a very open economy, so the business environment is becoming quite complex, where you deal with stricter regulations. So the regulations itself is becoming more strict in terms of the environmental or safety policies, but we also have to deal with the globalization. So if we want to sell to other countries, we have to adhere to their regulations. It also then opens up more competition for us, but also access to more customers. And then there's the new trend, no, it's not that new, but it's accelerating a little bit, is the industrial symbiosis or the circular economy, in the sense where one manufacturer's waste may be an important input for another company. So all of this is rapidly or majorly contributing to the increase in the complexity that enterprises have to deal with. This is an example of the left-hand side of it, so the very complicated product. And it has to do with, the example I mentioned earlier is modern luxury vehicles, where they consist of today, and this, it's last year, so it's still pretty new, they contain in excess of 50 electronic control units these days. Between those 50 units, you've got more than, and I think it's a lot more than 100 million lines of code. That's a fairly complicated product. To the extent that 40% of the market value of a vehicle, as you have it now, lies in the electronics and the software, and they estimate about 80% of the innovation. So as I said, it's no longer a mechanical object. This is really more software that you're driving. Just can be a bit scary. So what the three major brands of luxury vehicles in Germany did, and this is now Volkswagen, BMW and Mercedes, they each realized that they employ thousands and thousands of software engineers, and it's quite an expense. So they got together and they formed the AutoSAR Alliance. And they essentially relocated quite a large number of their software engineers into a central company to develop the base code, or the base infrastructure, if you want to call it that, for these luxury vehicles. And then they decided, or they agreed, that they will compete only on the implementation or the use of that software. So they sort of they outsource the base development of the code, and more importantly, the certification of that code in terms of safety and regulations and so on. So the answer here for them, and it was fairly successful, was collaboration. And what we're proposing is similar to that. So just quickly, as I said, there's changes in industry where you previously had an OEM, and many of the items, if you think back of something like some of the American branded cars, they manufactured almost essentially everything about the car, and they assembled it on premise and you drove it out of the factory. So you had OEMs, and they were supplied by tier 1 component suppliers, and they were in turn supplied by their suppliers, so subcomponent manufacturers and equipment manufacturers. It doesn't really work that way anymore. You've now got, even though they are still called original equipment manufacturers, many of them in fact don't manufacture a single thing anymore. Even traditional industries such as defense, where you have Rheinmetall Air Defense, who don't manufacture a single component of any of their products. I think Apple is also well known. They don't manufacture anything, even though we know them as a computer or iPod company these days, I should say. So we've got the OEMs, and they're supplied by tier 1 system integrators, who also in many cases don't manufacture anything, and they in turn supplied by their subsystem integrators, and here at the bottom you've got component suppliers. So what really happens is, because you've shifted down the actual manufacturing, you've got a lot more manufacturers. So smaller companies, more specialized companies manufacturing smaller components which will then eventually be integrated up this value chain. So the problem statement that we're seeing, and this is not the only problem, this is a problem of this new landscape, this new age we're entering, is we've got OEMs on the one side, and this is just an illustration, courtesy of my wife, and we've got smaller companies. It doesn't necessarily have to be SMEs, but the focus is slightly on SMEs here, and there's a chasm or a gap between these, and it can be due to many things such as regulations or supplier development, IP management. There's lots of things that cause this gap. It can even be the unknown or the fact that the OEM doesn't know about SMEs that can supply to them. So there's a bit more elaborating on the illustration. The OEM may say, I need some or other component, and some SMEs, maybe several of them, can say, I need or I can make this. But how does this SME get it to that one? And the key here isn't about the physical product anymore. It's about the information that describes the product. The information or the knowledge these days is much more valuable than the product itself. Especially if you talk about something like regulatory compliance. It's no longer the most difficult. The most difficult part is no longer putting together the locomotive or the power plant. It's about designing the power plant by using the information provided by your many suppliers. So what we're proposing is a platform, something that connects these, something where they can work together a little bit better. And we just called it arbitrarily industry collaboration technology. And we used a definition of technology developed at University of Pretoria by the late Dr. Richard Weeks, where technology consists of systems, context, or in a specific context, and operated or used by people. It's an interesting definition because we tend to think of technology as hardware and software. This one is a bit more complete, if you want to call it that, where the systems is the hardware and the software, and also the process that the technology is used. It can be used in a specific context. So I think you may agree that most of our what we call technological innovation isn't really development of new systems or hardware or software, but the use of current hardware and software in a different context. Something like the Internet of Things is a good example. It's nothing really new. We've had the internet for a while. The context is changing, where we now have a fridge connected to the internet, and it can talk to you, and it can tell you that it's empty, or even order food for you without your intervention. And then the people obviously also has a major part to play in the technology. So this is specifically not the people developing technology, but the people using it, people benefiting from it. So I'm quickly going to go through those three for what we're proposing. And so the system part I'll get to first. And this is what we call product lifecycle management. This is current systems and processes as a sort of an approach to business. It's nothing other than really your traditional CAD, so computer-aided design, computer-aided manufacturing, simulation and analysis type software. But the sort of the change that's occurring now is we've got platforms or systems that sort of form the gel or the glue between all those disparate parts that we previously had. So you've got a database, if you want to call it that, that can integrate information or data from the designers, from the manufacturers, from the procurement people, all into one database. So it's important to realize that, as I previously said, that the value now lies in the information that describes the product. And what makes PLM such a desirable system for this application is the fact that it integrates on 3 axes. So obviously we've got from the product life cycle, from the initial idea to the eventual disposal of it. That's fairly traditional. We know about the system focus of products, but it also integrates between your different disciplines. And this is not only engineering disciplines, it can also include computer sciences and material sciences. More importantly, and this is the newer development, is it can integrate your supply chain. And this is what I mentioned previously, where you can have a platform of the OEM, for example, and Boeing is a good example of this, Jaguar Land Rover as well. They make a platform or a system, product lifecycle management system, available to all their suppliers. And those suppliers then work on that platform so that the information is readily available. It can be more easily certified and integrated into the bigger product. If we look at the context, it's quite simply South African industry. We've got some symbols there that are showing the industries. It can be even more than this. This is the current focus. This product lifecycle management technology can support 14 of the 16 sectors. The ones not really interested in this type of thing is the business services, and the other one is arts and crafts and so on. And it also fits quite nicely into the advanced manufacturing domain, where product development is the first one there, and product lifecycle management is a technology that greatly assists with that, but also with the other 3 of that. I think I should hurry up a little bit. So the people, our focus, obviously, the CSIR is mandated to do good for the country. So our focus is on the smaller companies in South Africa and the larger companies. So if we sort of categorize enterprises into those 3, otherwise of the large global enterprises such as General Electric or Bombardier or so. So the people in this case are the people who would use this technology or this system that we're proposing. So if we put those 3 together, we've got the context or the industries at top, we've got the people here in the middle, and the system here is the thing that makes it possible to connect these people with each other. Now, why do I keep harping on about SMEs? It's because they essentially, and I mean with this with respect, they need the most help at this stage. There are some analyses that show to set up an engineer's desk in Europe at the moment costs an average of 33,000 euros for a single engineer. Now, we certainly don't have that kind of money to help SMEs. So this is a study done, I think, by a few Italians. It was presented in the Netherlands, where they showed how much benefit SMEs, smaller companies, gain from being networked, connected to one of these platforms. And most of the benefit, and this is a logarithmic scale, so it becomes quite big in hours saved. Most of it has to do, I don't have to go through all of this, but most of it has to do with finding information easier, not wasting time on searching for something and redesigning something that you may have done previously. So this is what we're actually proposing. We don't want to develop anything new, but we want to take current systems, and this is just an illustration of product lifecycle management as we know it at the moment, and put it in the cloud. Now, there are some product lifecycle management systems in the cloud. This is also not something new. But we need to make it easier for companies in South Africa to use it, because we need them to use it to become more competitive. As I said, to improve your manufacturing competitiveness, you need to improve your engineering. So we also don't want to just give them a system and here, go ahead and use it. We want to make it usable for them. We want to create sort of starter packs, if you want to call it, something industry specific. It may even be supply chain specific. So if we have a smaller company in South Africa who wants to supply to Denel Aerostructures, who in turn supplies to Airbus, they need to have the system set up in a way where they can start working faster and easier, but it still helps them to comply to the very complicated and very strict regulations, and they will make use of the type of symbols and information representation that Airbus at the end of the day wants. We can't expect them to buy these things. It's actually millions of rands to buy this software, and to configure it and to get it into your organization is even more. It's even more expensive. So it's simply taking stuff that's currently available, putting it in the cloud for South Africa, and I know we have some internet problems, but it's not everywhere a problem, and it will become better. We know that. We have to think of the future here. Making it available, so making it easier to adopt for them. But we realized it's not that simple. So just making it available isn't really the obstacle. We also need to help people to use it. So what we're doing right now at this moment is we're creating the first of what we call a local knowledge center. And it's quite simply a big room or two where you have some workstations available with the software configured in a way that it's easier to use in a specific industry. And this room can then be used for co-creation, which is one of the newer buzzwords, or collaboration, if you want to call it that. So people can come in and use it and experience this new way of working for themselves. And it's also a way then how CSIR can perhaps a little bit better assist industry in tackling some of the bigger problems or the more sophisticated problems. This can obviously also be used as a classroom for hands-on or practice-based training. So we want to make the platform available to people, but we also want to upskill them to use it effectively. So this is also a good way to do that. And the first one is will be here on the campus, actually just in the building next to this one. But we're also talking to the Cape Peninsula University of Technology, where they already have a similar type setup, and we can then leverage that for, again, this type of local knowledge center. And there are many other opportunities at other universities and other organizations across the country. Finally then, this local knowledge center can also be used for professional services such as advanced simulations, where a smaller company can perhaps not afford to, or it doesn't make sense to buy a simulation package or an analysis package, and then we can use this software to run some sort of a simulation or problem solving exercise for them. And finally, the future. We think this platform, if it sees pretty wide adoption, can be used for a few more advanced things. So if we have a whole bunch of companies perhaps using it, it may give us some additional insight into the market of South Africa or the industry. More interestingly though, we can drive procurement or tendering or contract management. So if you think of an example such as Armscore putting out a 700-page spec to its suppliers, and yes, most SMEs in South Africa do not have the time or the money to go through those 700 pages. So it's entirely possible, and this already exists, for Armscore to put the desired product or the desired system in this online cloud platform and show the pieces that it will consist of, and then potential suppliers can indicate that they can supply those pieces. So you just minimize or decrease the amount of admin for the smaller companies to go through to supply to Armscore or any of the larger companies for that matter. And then very interestingly, this platform may become a place for brokering or facilitation of professional services. So not only will you be able to give information of products or products that you can provide, you can also see potential suppliers, and we can put suppliers and purchasers in touch with each other, so can become a brokering or facilitation type service where people can get in contact with each other. And that's it.